history sequence that before about the Crimea and then about Belarus. Of course, the Crimea is some very special point on the planet. I shall not tell much about our epic travel to there by car, 3,000 kilometers afar. I shall not tell about travel back through the war zone because we had a lucky chance to get back just 1 week before the war was started in the full scale. But everywhere it was easy to see that something is brewing up. The main aim was a technology transfer, of course. Our main interest was how to learn to produce astronomical large mirrors. Firstly, the metallization technology, and secondly, if chance gives that, in carving and grinding technology too. Because at least as they tell themselves, they are most advanced mirror making establishment over the world, which are much more precise than the Germans, Americans, and even Russian Lomo. And they use a quite understandable technology which you can make up everything yourself, and it's more about know-how, not about buying expensive things. Of course, we need to give something back to them. So we agreed that they shall show us how to do the things. We shall help them replace parts in their vacuum sputtering machine. They had a very sophisticated machine, which was, this. Which was for 78 parallel interference layers to put the glass over the glass, but it was based on a very old Russian computer which take a control over every process in that machine, and that was computer of 80s, early 80s, so it was completely collapsed and no possibility to repair at all. So I had ideas that we should just put in the hands big scissors, cut the cable, and put the simple solution, which is very modern nowadays. It's Arduino Mega. So this we produced it at the place. Happily, the technologist was quite good and even much better as we in C++ programming. So together we get that everything is working. Of course, there was some. It was not simple job. You see, about 100 wires we must detect from where to where, what inside, and so on. But in those weeks we get that. Then we had some problem about the vacuum pump, which needed a repair. So it's nice size of vacuum pump, yeah. And it's PC black from inside. Oh, it's much to scratch. Then here is the central. Manual driving unit where you push the buttons and everything starts to whisper. Yeah. Okay, now, but the main things are, of course, this grinding technology. They're not allowed to make pictures, but we made a drawing and wrote the technology very carefully. Then we had the occasion to take our own example, our own experience about metallization, hands-on. And that mirror, what we metallizated, was quite good. So practically now we know what we did incorrectly here. And the main lesson is just very simple. Maybe I had some wrong imaginations that Aluminium, what you are spreading over the mirror, it should be just clean aluminium, but nothing special. But no, it must be so clean that you should find most cleanest what is in the market. If it's the least additions to that aluminium, they make some irregularities and then this aluminium scratches off. To make a good adhesion, it must be clean. And especially the alcohol. They had checked all the alcohol plants in the Soviets, and only one had good enough alcohol which had good quality of the mirror outer can. All other had the same problem as we had. We used just some butyl alcohol, and this layer is not attached to the mirror. Yeah, so we need this probably 5-star alcohol. Yeah.
Where is it?
Just they are doing own cleaning after the buying the alcohol. And then it's very interesting machinery how to test, do they have grinned the mirror correctly, that geometry check-up. It's just a large standard mirror and laser, simple laser which make an interference on that entire mirror, and you see how much they are differing. At first I was a little bit scared about how we shall get such reference mirror, but then they explained that it's not so heavy, just such mirror is needed when you are producing a parabolic mirror. If you are producing spherical mirrors, then it can be tested on its own. Just you are using instead of this mirror, that's what you are producing, then it makes it's much more simple. For example, here I photographed a very interesting system, how they balancing that mirror, let it not make some deviation of geometry due to gravitation. It's just a counterweight system, which is everything is adjustable, and it's really sophisticated technique, but you can copy that. It's not second world wonder, it's just to repeat. Okay. What else? Aha, here's one photography what was on that border where they asked to switch out the camera. It's Sital plate with drillings. It's already made a semi-round, and next step is a grinding bench in which it's carved in a rough. It's making that maybe centimeter hole, and then next step is next stage is fine grinding, and then in the 15-minute term it must be metallized. It's very important that it means that grinding and metallization must stay in the one and the same place. You can't make one process here and another in Baldwin or somewhere else. It must stay in the one place. So, actually, after this visit, I think we, both with the visitors, clearly understand that what we need, what must be done. Of course, that's a quite big job in the head that we shall do every day nearer and nearer, but in the plans are that sooner or later we shall be capable to produce large astronomical mirrors and renovate old. When the future will show, but we are going on that aim. Okay, about the Belarus. Belarus, that was a little bit less epic travel. It's quite near, only 800 kilometers. And yeah, that's right. just they had experts status about heat Mo Institute of Mass and Heat Transfer, the expert status of say plasma torches. And our problem was how to get the high temperature plasma in normal atmospheric conditions, which are able to melt calcium particles, nanoparticles. The deepest reason why, you can see in the bottom floor where the poster is hanging on that, I think number 20, poster number is 20. Here is one of possibilities, the 433 megahertz flame, but they a little bit brainwashed our brains that its effect was generally known, but no one was understanding that it's with so clear words that as lower the frequency of plasma, as more unbalanced this plasma stays. Just it means that it's very high electronic temperature, but very low ionic temperature. And only for a very high frequency plasma, the balance is quite good. It means that electronic temperature is near the ionic temperature. It means that plasma is hot. If you need a cold plasma, go to megahertz. If you need a hot plasma, go to gigahertz. So we a little bit analyzed how much such project would cost. Microwave torch is much cheaper and easier to replicate. How it's built? Just the oven, kitchen oven at the left corner, magnetron. Here is one very expensive and specific detail called a circulator. It's unavoidable, you must buy. Without of that, nothing is possible. The next part is in the right corner. It's say analog of resonance contour, which is say the tuner, 3-knob tuner, and after that is just a small box in which the gain wave which are traveling force meets the wave reciprocated from the mirror, and where the both maximums are falling together, just the a maximum is overstepped and starts flame. Just microwave are giving you wonderful flame, which is look excellently is what we need. But the complex of just raw details cost about $3,800, and somehow we are struggling about a half of year to buy it, and last answer was no. But I hope that my yesterday activities was leading to that we found the source where to buy it in the nearest future. So probably it will be built. Here's from other records. That's a tuner in the center. This adjusting knobs. The next, here you see, and this in the right side, that's ecranated, this torch ending. This ecrane is only because to not poisoning ourselves with microwave radiation. But when it's far enough from this waveguide, it's no more poisonous, so the ending can be opened.
Hey, it's pizza.
So, here you see now, now you see that about this flame. This flame is going out. Of course, we need the flame to settle down, so we should apply it hands up, hands down, and feet up. Here is one very important invention of them. they allow it to copyate it in some extent, so this flame must have some igniter. And this is that ignition box, which contains the two patents, and so we can use it. It's electronics inside, so we sniff it even that level. So we know how to replicate, and first the PCBs are already made for that. This is that most secret detail. Actually, it's very interesting detail. It's high voltage transformer which feeds that plasma igniter, and ignition must end immediately as current begin to flow. And they invented that. They push this transformer in a resonance, and as soon as the current are making virtual short of this secondary winding, it's shorted the parasitic capacitance too with the same. That's why it slightly changes the resonance frequency of this transformer, and it falls out of the resonance, so the current is falling, and everything is secure. Okay, here is some drawings what we copied with a millimeter accuracy, so I'm sure that we shall be capable to just copy the good design. And if we can, then it means that becomes realistic to make some human parts growing device. Just if someone broke the leg and lost the bone, it's possible to make equal bone, which is biologically grows in your bone, and it's as chemically as biologically the same. And even living cells are inhabiting it. Of course, it's far future, but it's a nice dream, isn't it? Okay. Yes, it's some more very nice their secrets. One of the secret was it's just very interesting microcircuit, or I would say sensor, which is capable to measure very small gaps and magnetic field and current. They was using in that circuitry around that torch, and we should play with this too. It's a very unique detail. And very cheap, actually. Another, their secret is one specific thermometer. What a year ago we tried to construct ourselves. It's just for measuring the temperature in the hard field of radio frequency driven induction oven. Just any electronics is burning down in such radio frequency field. But they invented a semi-optical principle how to detect the temperatures, and very, very exact. You see here is some control features, and this thermometer cost only a few $1,000s. So after that visit I understood that we have nothing to do in that field, everything is already made. And if someone needs such, he can just go and buy. So every visit gave some technological benefit or scientific benefit, and we are very happy that we had such occasion, especially about Crimea, which is maybe closed for many tens of the years, which is that what we gave with us. It's all we have. Now the border is closed, people are dying, so it happens. Okay, thank you.